Okay, good morning or evening or night, whenever you're watching this. So this is looking at volume and capacity of cylinders. Now, this is going to be looking at a couple of different options here, but mostly just prisms and cylinders. So this is probably the shortest one of the entire class or the entire module. So we're looking at volume and capacity. And now these are two very, very different things. Now, capacity is the amount of liquid an object can hold. Okay, it is referring to liquids, so liters, milliliters, gallons. Volume is how much space an object takes up, and that can include solids, liquids, and gases. One way to think about this is if I have here we go. If I fill a glass with sand, I'm filling it not with a liquid, right? There's a volume amount in here. Maybe this is 600 cubic centimeters. I measure it with a distance. Whereas if I were to fill a glass with milk, I'm filling it with a liquid. We measure that in liters, milliliters, gallons, stuff like that. Okay. So there's the difference there primarily is that again, volume is equal to space, and it's usually stuff like millimeters, centimeters, meters. Whereas capacity is liquid measurement, things like milliliters or liters or gallons. So I do want you to write that stuff down, the stuff in the red here. So that's the difference here. Again, volume, object of a measure of how much space it occupies. Capacity is how much it can hold. I like these definitions up here. It's a little bit simpler. Things can have both a volume and a capacity. They can be both, right? That same glass with the sand and with the milk, that can hold both volume and capacity. Some solid objects, for example, though, like they use like a cement block here or like a brick, they only have volume. I can't put anything in them. They can't make it hold any more liquid. So again, when we look at volume, we measure this in a cubed unit. So when we have a line, that's just a meter, right? If I have area, that is meters squared. If I have volume, those are cubed. I'm looking at how much space can fit in them. So that's the primary difference here. Um, so one thing to note here is that 1,000 centimeters, a thousand cubic centimeters is 1 liter. And in terms of like, what does that look like? What's 1,000 cubic centimeters? Well, I'll give you a hint. If we're measuring just like a rectangular prism, its length times width times height. 10 times 10 times 10 is 1,000. So a 10 centimeter cube can hold a liter of liquid. If I were to give you a meter long cube, if I were to give you, it's a meter tall, meter wide, meter long, that would hold 1,000 liters. So you are going to need this stuff. You are going to use this stuff actively. This is something you need to remember. This first part specifically is very, very important and is used a lot in the questions. So, for example, if I were to ask you, how much space does how much space, or sorry, let's change that. What is the capacity of 5 liters of water? If I were to ask you something like that, well, 5 liters is 1,000 centimeters, or 1,000 cubic centimeters, so it'd be 5,000 cubic centimeters. So it's really important we understand like with the difference between again a volume and a capacity. And we'll try and like if you're still a little confused, I don't worry, it'll get reinforced as we continue to go on. Now there is a general formula here, which is essentially to find the volume of any prism or cylinder, you take the area of the base, right, of the bottom of it. Right. So if I were to give you something like, let's say I give you a rectangular prism here. Here we go. So I give you a rectangular prism here. We're looking at it from the bottom here. Um, this part That's the base, right? So if I find what the base is, oh, well, that's the area of the base, the surface area. Oh, that's a length times a width thing, right? And then I times that by my height. Now, this is the same even if I were to give you a cylinder as well. Now, there's a little magical, I'm kind of zooming in here. If I were to find the area of this circle here, times that by the height, it's the exact same thing. So there are multiple formulas here that you're going to get. In fact, let me load up your formula sheet here. Bear with me for 1 second whilst I find it. Uh, Okay, so I found it. I realized I never uploaded it. I gave you a printed copy if you grabbed your extra printed stuff. Again, not just the workbook. I gave you extra stuff. So I did upload it on the LMS here. It's the formula sheet here. Now that looks something like this. So you are going to be given this as an FYI. This is some stuff you get to know. And now, okay, I do give you these capacities, but the big thing, you still want to be able to remember these things here. So again, 1,000 cubic centimeters is a liter, which also means 1,000 cubic centimeters is 1,000 milliliters. And if we know what a liter is, 1,000 milliliters, and so on and so forth. So just as an FYI. So let's continue going here then. So again, just like before, we're not going to go into the solution down here. So we have a rectangular prism that has a base that's 15 by 20 and a height of 20. We want to first ask them two things. What's the diagram? And then calculate the volume, not the capacity, the volume of it. In this topic, 3.3, 3.4, you need to read carefully. Because oftentimes they are going to ask you to do 2 or 3 or 4 things. So you've literally noticed how I've gone and said, okay, task 1, task 2. Let's do task 1. Let's draw a rectangular prism. So how do you do that? How do you draw a 3D shape? Well, you start with the shape, a rectangle, right? So then what you want to do is you just want to do a nice little like angled line. It can be as long as you want, but if I make it this line, I'm not long, this one needs to be that long. This one needs to be that long. And then you just draw straight up and down, left and right lines to connect them. Now you could even do this one as well if you really wanted. There's nothing saying you can't do that. Totally fine. It doesn't have to be perfect, but you're so a rectangular prism. Now the base, right? The base is this part here. It is 15 by 12 with a height of 20. Excuse me. I apologize for your ears. So 15 by 20 by 12. So again, volume, volume, volume. What's volume? What's volume? What's volume? What is the formula for volume? Again, it's really universal. Now, I've tried to give you a couple of them, but at its core, it's this. It's the area of your base times your height. And I'm always going to go to that. So again, the volume of a prism is equal to the area of my base times my height. Now this is a rectangle, right? So what's the surface area of a rectangle? It's length times width. And then times that by the height, right? So I know my length is 15 centimeters, my width is 12 centimeters, and my height is 20 centimeters. So then you just go 15 times 12 times 20. And you'll get 3,600 cubic centimeters, right? Again, how many centimeters am I adding up here? 1, 2, and 3 of them. 1, 2, 3, cubic. And you'll double check. I'm doing volume, right? Volume is always in cubic. So I've done that. Check, I've done that. Now I want to calculate the capacity of it, right? So when I look at this, this means I am turning volume, right, which is centimeters, into capacity, which is milliliters or liters, right? So I got to stick with something I know. Now, okay, centimeters cubed. Do I have anything? Yes. 1,000 cubic centimeters is 1 liter. So if 1,000 cubic centimeters is 1 liter, now you could probably just look at this and be like, oh, it's 3.6. But if I were to give you a harder number, you might not be. So I'm just going to divide it by that, right? And if you remember unit 1, oh, well, sorry, what was my, yeah, here. These are liters and these are centimeters cubed. So if you remember from unit 1, we can also express this as a ratio. Remember when I said this thing comes in handy? It does. So for example here, 1,000 cubic centimeters is equal to 1 liter. Now, if I know that I have 3,600, you could just, oh, what's the magic number? What's the magic number? 1 times something gives me 1,000 times something gives me 3,600. 3,600 divided by 1,000 gives me that magic number. Again, if I were to give you harder numbers, you wouldn't be able to eyeball this, right? So it's important to understand why, like how it happens, not just be able to look at it and be like, oh, well, it's obviously 3.6. So 3,600 divided by 1,000, or 1 times 3.6, either way, I get 3.6 liters. Or could also be 3,600 milliliters, right? Because that's the same thing. So I'm actually going to go up here and I'm going to add that fact in here, which is that 1,000 cubic centimeters is equal to 1,000 milliliters. Okay, so let's continue going here. So build your skills here. In this case, I think you guys can do these. I'm going to do one of these, but I trust you guys to be able to accomplish it. So 3, 2, 1, I want you to go do it. So 3, 2, 1. So again, a good thing to do if you're not sure where to start for more complex problems is draw the actual diagram, which I've done on the right. So again, volume is equal to the area of the base times the height. Now my base is a rectangle, right? So I'm going to take those two measurements, the 15.7 and the 18.8, and times by the height. When it's a rectangle, it's pretty easy. You just multiply all the numbers to find the volume of it. It's not so easy with some of the other shapes, though. So in this case, it'd be 3,689.5. The 3,698.5. 0.5 what? Well, it's centimeters, and because it's volume, I'm multiplying 3 centimeters. It's cubed. I'm going to circle my final answer. I'm going to trust you guys to be able to do those ones. All right. I'm going to zoom in here. I know it's a lot. So a rectangular prism has side lengths of 7, and its volume here is 392 cubic centimeters. We'll focus more on this in the next one. You're not going to have to do any algebra. This is an algebra question, but just in case you're interested. So again, I know that the volume is equal to, it's a rectangle, right? Area of the base, length times width, right? Actually, I'll still put the area of the base, sure. Right? Good maths, right? Which I know is length times width times height. Now, it tells me what the volume is. It tells me the volume is 392 cubic centimeters. I'm going to write that in here. Now, the length, so the length and the width, right? The area of the base, well, it's a square base with sides of 7, right? So it's 7 times 7. And then the height is, we don't know. So technically, what I have to do is I have to multiply these to get 49 centimeters squared. This is, 392 centimeters cubed. I would need to divide both sides by 49, essentially. Because I wanted to tell me that, hey, your height is equal to the answer, right? So if I do that, these cancel out. Now 392 divided by 49 is 8. So in this case, the height would be 8 centimeters, right? I'm measuring a distance, which means it's 1 centimeter. Now, if you're looking at this, you're like, I have no idea, not a clue what he just did. That's fine. This is a unit 4 thing that we will spend a lot of time on. So if you're looking at this, you're like, I don't get it. That's fine. You're not gonna have to do this unit. Don't worry about it, and we'll teach you how to do this stuff next unit. So we're gonna skip these ones just because of that. If you understand what happened here, I do encourage you to try this. It's really good practice. So we're gonna skip question 2 and 3. We can try this one, I think. Question 4. I'm pretty sure we can do that. Yeah, let's do that. Okay. So Patricia is in charge of the excavation for the foundation of the building. A hole must be dug that is 35 by 25 by 12 meters. So, question one, how many trips will be required to remove the dirt if a trailer can only carry 15 cubic meters of dirt, right? So, like, imagine you have a giant pool here, a giant pool, and I give you a bucket, and I say, here, it's filled with water, yada, 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 here's your pool. And I say, give you a little tiny bucket. How many bucketfuls are you going to have to splash out of there to empty that pool? This is the same principle, right? Here's a big hole, and we're going to dig it out, but those trucks I'm dumping that dirt into can only carry so much. How many trips am I going to have to do? It's very real world math that needs to happen, right? Whenever any objects, any buildings planned. So let's start out here. Again, I'm going to draw the diagram. You don't have to, but it's a really good habit to get into. A lot of people are really visual learners. So it's 35 by 25 by 12. It doesn't specify one's height, one's this, one's that, so we can just put them wherever. Right, so let's start figuring out here. Well, we got to figure out the volume. We have to figure out the volume, and then once we do that, we need to take the volume and divide it by 15, right? Because that's how many trips it can take. So that's what needs to happen here. So the volume in this case, okay, it's the area of the base times the height. We're going to say 35 times 25 times 12. 35 times 25 times 12 meters is equal to 35 times 25 times 12. 10,500 what? Meters cubed, right? You want to make sure we're doing that. So I've done one. I'm not done yet, though, because the question asked me it doesn't ask me find the volume. It asks me, how much dirt do I got to take out of here, right? So if my little tiny truck here can only carry so much dirt in it, this is not a good truck. You get what I'm saying. How do I figure this out? Well, if this is how much dirt I have, why can I not just divide it by 15, right? This is how much dirt there is. If I get 15 per trip, this is going to tell me what the answer is on how many trips. Divided by 15, 700. It's going to take 700 trips. So the answer here is it will take 700 trips. You're not done if you just write this. This is not just a complete answer. It's asking you a question. Give it a statement. Don't just be like, all right, I wrote 700 and move on. Say what the answer is in this case. All right. Your favorite things, right? Now there's two ways you can do it. It doesn't matter which one. You can either cut it this way or you can cut it this way. I want to see which one, how did they do it? They did it that way. I'm going to stick with this way. So here's shape one, here's shape two. You have two examples to follow from. So shape one, right? The volume of this thing, 9.4 times 4.2. Then how long is this line here? It's same as length as this line, which is the same length as this one. So 6.6. Right? So take shape one, add shape two. Write your little formula on top, right? Shape one plus shape two. So shape one, volume is equal to the area of the base times the height. My base in this case is a rectangle, right? So it's length times width times the height. 6.6 times 9.4 times 4.2. You multiply all those bad boys together. You get 260.56, 260.6. And what's the measurement? It's centimeters and it's volume, so it's cubed. So check, I've done that. Now let's go off and do shape two. Now, what is shape two? It's a rectangle. It's a rectangular prism, right? So I'm still going to stick with that same formula, which is volume is equal to length times width times height. What's my length of shape two? We'll go with 16.8. What's my width? 6.6. What's my height? 7.5. So you just got to multiply those together again. 831.6. Perfect. So the volume of shape 2 is 831.6 cubic centimeters. Now remember, I'm not done, right? I got to add these two shapes up. So 260.9 plus 831.6 will give me, here's, it'll be 0.529 10. 1092.5. 0.5 what? 0.5 what? We gotta be really specific here. Cubic centimeters. Yeah, I'm done. No, you are not. Again, this is a very easy unit to miss stuff. It wants the volume and the capacity. Read the questions carefully. You notice how the last thing I did before I moved on was I made sure I went back to the question to double check that I answered it correctly. So I now need to convert this into a capacity. How do I turn cubic centimeters into milliliters or liters? Well, luckily, you guys were given a formula for that, right? So, okay, I know that if 1,000 cubic centimeters is equal to 1 liter, well, then I just got to divide this by 1,000 to figure out how many liters, right? And I'll get 1.09. Oh, gosh. 1.0925 liters. Or we also know that that's just 1092.5 milliliters. These are the same things up here, right? So circle both my answers here. Read the questions carefully. All right. So there's a solution for it. Yada 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 yada. I no, skip question 3. We just did that. I want you guys to do this one here. At this point, I trust you to do it. We had good practice with this last time. So I trust you to do it, right? Split it up into shapes. You're either going to have shape 1 and 2, or you're going to have shape 1, 2, 3. So I trust you guys to be able to do this at this point. If you're not sure, let me know. I will give you guys the answer here in just a moment. So 3, 2, 1. Okay, so for question 6, you should, again, pause the video to actually do it, but you should get 4,464 cubic meters as your final answer there. Now, same thing, I want you guys to do, actually, you don't have to worry about question 7. That's an algebra one. You're welcome to try it if you want, but I'm not going to force you guys to do it. Kind of a tricky question. We don't care about algebra right now. That's the next good thing. All right, so moving on. So prisms are really easy, right? Prisms are just length times width times height, right? Not that bad. We're going to change it up a little bit, though, and now we're going to work with cylinders, right? It's the same thing, though. The volume is the area of the base times the height. But the base is a circle, right? So the circle in this case is pi r squared times height, right? This is the area of a circle times the height of it, and that gives you the answer here. So if I give you a can of tomato sauce with a radius of 3.8 and a height of 10.2, well, again, I'm going to draw my diagram here. Here's 3.8. I'm going to write r just because I'm not going to have a lot of space, and 10.2, right? So what's the volume of the can? Well, the volume is equal to the area of the base. I don't have a lot of space, so I'm just going to write the area of the base. Instead of that, it's pi times r, right? Pi r squared times the height. Area of the base times the height, right? So that's pi times the radius is 3.8 times the radius, which is 3.8, times the height, which is 10.2. Boom, 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 boom. 3.8 times 3.8 times 10.2 times pi. 462.7. Volume is equal to 462.7. 0.7 what? Specify cubic centimeters. And then how much tomato sauce in liters can that hold? So sometimes it specifies. So just like before, right? If I know that one, I'll just write it in. If I know that 1 liter is equal to 1,000 cubic centimeters, then I got to figure out how many liters does 462.7 cubic centimeters fit. And you can do this a couple ways, right? The one way is you could do that magic ratio we talked about, right? So 1,000 times some magic number gives me 462. It's obviously going to be smaller than 1, right? Like 1,000 times half, you're half in 1,000. That'd give you, a smaller number. So you can figure that out by going the opposite way, 462.7 divided by 1,000 to find that magic number. Oh, so I timed it by 0.4627, or you can just take this number and you can divide that by 1,000. And either way, your final answer in this case will be 0.462 liters. Or you can even just go 0.46 liters. That'd be fine too. Either's fine. But so just important to be able to go and do that. All right. So just like before, I want you to do it. I want you guys to try this one here. I fully believe in you. 3, 2, 1, go. Okay, so first thing you should have done is, right, figure out your area of your base, which is your circle. Now that said, there it gives you a diameter of 15. I don't care about the diameter. I want the radius, right? So the radius is half the diameter. So half of 15 is 7.5. Radius is 7.5. All right. So it's a circle. So my base is pi times r squared. And that just comes up by the height, right? So pi times 7.5 squared times 36 gives me 6,361.7. The volume is equal to 6,361.7 cubic centimeters. Yay, I'm done. No, I'm not. It wants the capacity as well. Read the question carefully. So that means I got to turn this into the capacity. I got to turn it into milliliters or liters, right? Doesn't matter which one you pick. At this point, I trust you guys to do it, right? Divide it by 1,000 to get to liters. So it'd be 6.36 liters. Or just move the decimal place. Or just like keep it 1-to-1, and it's just 6,361.7 milliliters. Either's fine. I don't care which one unless it specifies. So check. That's the full question. I'm gonna get you guys to do this one here. Same thing as before. I'll give you the answer. So 3, 2, 1. Make sure you guys are doing that. Remember, it's volume and the capacity, and each cylinder has a height of 20. So 3, 2, 1, go. Okay, I don't know where I stopped recording, so I'm just going to quickly review everything. So for this one here, example 4, I found the volume of my can, right? Volume of the your area of your base here it's a circle, so it's pi r squared times the height. And then to turn that volume into a capacity, you need to divide it by 1,000. Now for this one here, same thing, right? Volume of the area of my base, it's a circle, so that's this here. This is the area of a circle times the height. Now, in this case, the diameter was 15, so that means the radius needs to be 7.5. So I multiplied that. This is the answer I got as a capacity, sorry, as a volume, but I have to also turn that into capacity, and either milliliters or liters works. For this one here, I just gave you guys the answer. I did recommend that you do go to 33 liters instead of 32,967 milliliters, right? I don't measure the distance from Saskatoon to Regina in centimeters. I don't say that it's 2,982,000,000 centimeters. I say it's 200 kilometers. But those are the answers. Don't worry about question 10. So at this point, you guys should be able to do pretty much everything here. I'll just quickly double check to make sure there are no questions that you cannot do, but they should all be doable. Okay, so you guys should be able to do everything here. That said, 5 and 6 are kind of tough. So I'm not going to expect you to answer. I don't think I asked you to do whatever's on the LMS, but I'm pretty sure I don't ask you to do question 6 here for the actual assignment. If you're struggling with it, please ask, but they are tricky questions. Don't get too frustrated here. One thing I do want to note here, though, is Keep in mind, this is 15 liters. You might want to convert this into milliliters or vice versa. So you just have to be wary of the measurement that you use. As for the rest of it, you guys should be fine to go, except question 4. There's centimeters and there's meters. You got to make sure that they're all in the same. So you're either doing 6,000 centimeters, 450 centimeters, and 15 centimeters, or you're doing 6 meters, 4.5 meters, and 0.15 meters. I'll let you figure out which one you think is best for this in this case. But okay, so you guys should be able to do this. Any questions, let me know.